Hello, this is John from caveofprogramming.com. In this tutorial, we're going to set up a project that uses the libraries that I talked about in the last video, which hopefully you've now acquired one way or the other. And if that was a struggle, I do sympathise, because sometimes it is if you're using Linux especially, or the Mac. But hopefully you've got that sorted out. So because I'm on the Mac here, I'm going to be using my my .a library, and I'm going to be using the header files that I downloaded. So I'm using Eclipse as well, and this is going to be slightly different if you're using CodeBlocks or Visual C++ or another IDE, but all C++ IDEs have the same basic ideas because it's still C++ after all. It's just that you might have to Google for instructions on how to do this for your platform. Let's create a new project. So I'm going to go to File, New, C++ project. I've actually got a choice of compilers here. I've never used this cross compiler. Sounds good, but I'm staying away from it for the moment. I'm going to go to the Mac compiler and a Hello World C++ project. Okay, and let's call this SDL Basic or something. I would call it SDL Test, but I've already created one of those for my own purposes. So let's call it SDL Basic. Click Finish. Let's add the paths to the library and header files first. So I'm going to right-click the project here and go to Properties, and I'm going to go to C++ Build. Let's expand that. And at the top here, so again, this could be different in different versions of Eclipse, and it'll be different for a different IDE. But once you've seen how this works here, you can apply this to any IDE, but you might need to do a little bit of Googling. So here I can configure my debug release targets, and I can also set things for all configurations. So I'm going to change to all configurations here because I want this to work whether I'm compiling a debug or a release version of the program. The difference is the debug version contains extra symbols which slow down the program a lot, but are helpful if you're going to use the debugger, which we're not in this tutorial, but you could do. So we go to all configurations here, and I'm going to go to settings, and I need to tell Eclipse, which is in turn is going to inform my program. Well, it's going to inform my C++ compiler where to find the header files. So let's go to includes here, down here, and I need to add an include path. And the include path is going to be the directory where I put my header files. So for me here, I'm using the Mac, and I use this MacPorts thing to download this, and it put my header files. I had to Google to find out where it actually put the things, but it put them in, let's do a history here. It put them in user local include. So let's go to CD, that directory, check they're really there, SDL2. Here are my header files, and so I need to put this directory, I need to tell Eclipse here to use that directory to search for header files. Let's go to include paths, click the green plus sign here, add that directory in, like that. Now I need to tell Eclipse where to find the SDL libraries. So let's go to libraries here, and I need to add the directory containing the libraries to the library search path here. It says -L there because it's going to supply a -L flag to the compiler in this particular case for this particular setup, which will tell it where it will add an extra library path for it to search. So let's go back and check where my libraries are, and they are in user local lib. So this directory here, if I go to that, then the library that I need is libsdl.a, and that's right. And to run my program is going to need libsdl.dylib, but somehow on my system it finds that anyway. It's possible that you may you may need to copy your .so or .dll file, I don't know, depending on your platform, into your program's working directory, but or into a standard directory on a system like Windows system or something like that. But on my system, it found this dylib automatically when I ran the program. So we don't need to think about that for the moment. So I need to tell Eclipse to search this directory for libraries. Let's copy that. And I'm going to click library search path, going to click the green plus here and add in that directory. Now I need to tell it what library to link with, and I need to tell it to link with this libstl2.a library. On Windows it will be stl2.lib. Now, although this is called libstl2.a, there's this convention that you don't mention the lib when you're specifying libraries, and you don't mention the .a, you just mention stl2. I'm not sure how this works on Windows. Probably you just have to tell it to link with stl2. You might have to put stl2.lib. So you can try both and see which one works. I'm not completely sure because it's a while since I've used Windows, but I'm going to copy that stl2, or I could just type it, click the green plus by libraries and put stl2 in there. So like I say, on Windows, I think you need to just specify stl2, but possibly it could be stl2.lib. I'm not totally sure. So, but one of those is going to work, hopefully. So now let's click apply and let's click OK. So now my program knows where to find the includes and knows where to find the libraries. Let's just build this project and see if we get any errors at this stage yet. So this is fine and we can run it. It's just a hello world program that runs on the console right now. Now let's add an include up here. Let's say include, and I use the angle brackets because I want it to look in a standard position for my header file. I'm going to say include stl2.h, and that file stl2.h must be present in that include directory that you just specified. Let's save this. I think I'm wrong there. I think it's stl. Let's actually just check here. So let's go to user local include. So although I've downloaded stl2, yeah, it's actually just stl.h. Okay, that's why I've got that warning symbol there, which is very handy. Okay, so we've got stl.h included. Now that should also work. You should be able to build it and run it if you've got the header, the include directory specified correctly. Now let's try calling a couple of stl functions just to check that this works. So I've got a little program that I already set up, and I'm going to just call this stl init and stl quit. So we've got stl init and we're telling it with this constant, which is in the stl header file, to just initialize the graphics mode. So let's type this out. Let's say if stl init, and we've got stl init graphics. Let's check that this is, sorry, stl init video. As you can see, I don't remember this well. I've done this several times, but unless you do stuff day in, day out, well, for me anyway, it doesn't stick in my head. And this function is going to return a value less than 0 if it doesn't succeed. That's why we say if stl init brackets stl, got that spelt wrong, init video is less than 0, then we need to return, we can return, let's say, 1 from our main subroutine here. That's a good thing to do, because usually you return 0 to indicate success for a C++ program, and anything else is considered an error code. But we're going to be running this program by hand anyway. We're not going to. It's not like we'll have some system that will run this program and check its error return code. So let's put in here cout stl init failed endler, and after that let's put if the if doesn't execute and we don't return here, we can put SDL init succeeded. And after that, to shut down the SDL system, we call SDL underscore quit. Pay close attention to the capitalization there. So we've got capital SDL underscore and capital letter at the beginning of the subsequent word, but the rest of it's lowercase. So yeah, there's no fixed condition about how to separate words or break up class names in C++, and they decided to prefix stuff with SDL and an underscore, which is fair enough, and then capitalize the first letter here. So we should be able to build this program and run it. And if you're using a different graphics API like Allegro or something, you should be able to do something similar. You should be able to initialize the system somehow and then deinitialize it with some quit type function. And you can easily find tutorials. For example, if I search for Allegro tutorial, I haven't done this at least for many years, but stuff is going to come up. You're going to find stuff that will show you how to create a basic Allegro program. So for Allegro, we've got apparently Allegro init, and you can bet that we've also got some sort of we've got some sort of function that closes down Allegro. So it's the same for pretty much any graphics library. You just need to get whatever the most minimal program you absolutely can run. You need to get that running and building basically at this stage. So this is a very, very minimal SDL program that does nothing at all, but it's going to test whether we can successfully link with the right library. Let's try building that. So we build it and we shouldn't see any errors. If you do see errors, then something's gone wrong. You're not linking with the right library, or you've specified the wrong path to your library or something like that. So you have to get past this stage. If you see any errors that are really peculiar, that you totally don't understand, absolutely put them in Google. And you could also add SDL in there, for example, and see who else has got those errors, because someone will have. So you're aiming at this stage to get a buildable program that calls, at least one or two SDL functions. Now let's run it. And it shouldn't do anything, it should just quit. So it says SDL succeeded. We expect to see that success message. If we get init failed here, you could try getting the return value from this function and then doing some Googling to find out what that means. Usually this won't fail. If it does, I'm afraid you're on your own. I don't know why it would fail, and if it does, you need to get into Google, I'm afraid, and do some Googling. Look for SDL init fail, check the actual error code from this, get the actual integer that it's returning, print it out, and try to Google for that code, SDL init error code, and look for what it actually means. If you run the program and you get a message about some dynamic library not being found, then somehow you need to make sure that your program can load the dynamic libraries it needs to run. So on Windows, you could try putting the .dll file in the same folder as your actual program where it's actually compiled to, or try putting it in a Windows system directory or something like that. On Mac, again, on the Mac or Linux, you probably want to make sure that your dynamic libraries are in some kind of standard folder. And if you still can't get it to work, then again, it's a question of going to Google and Googling for stuff, SDL dynamic library location or that sort of thing. On Linux and a Mac, you can also use various tools to find out what dynamic libraries your program is trying to load from which directories. So again, if you Google that, you'll find information about that. But you need to get to the point before going on to the next tutorial of running a program like this that initializes and quits your graphics API and can actually display some message to let you know that it has succeeded, at least in initializing the system, and then you can quit. So good luck with that. if it doesn't work straight off, then do persist with it, because believe me, as a C++ programmer, you're going to have to be persistent, and you are going to find yourself at some point with C++ Googling for information about error messages. But it's worth persisting with, because this is not theoretical physics. These are not or philosophy. These are not problems that are insoluble. Whatever problems you get, they can be solved one way or another. It's just you have to be persistent enough to figure out how to solve them. So don't throw up your hands in despair. Usually you can solve programs with an hour or two of Googling at the worst. In the worst case, it ends up being a thing that takes you multiple days. And what I usually do then is I try to look at it for like an hour a day or something until I finally solve the problem. But those are the worst problems. Unfortunately, it's a lot more difficult when you're beginning and you haven't got experience to solve problems. I used to sometimes spend a couple of days just trying to fix one bug, but I was a bit slapdash in my approach. So if you really try hard to be systematic, it really does help a lot. So I'll leave you with that, and good luck with that. I hope you succeed in getting some graphics API that can do pixel access initialized for your system. And in the next tutorial, we'll look at putting together a basic STL program that actually can put a window on the screen and allow you to quit the program, close the window. So until next time, happy coding.